Let's look at page 204 and talk about the sort of big rocks from this chapter. This is an introductory chapter to chapter 4, so we don't want to get hung up on the details right here. We just want to kind of grab the main ideas that we were supposed to understand. In lesson 3.1, we talked about graphing linear equations, and the main idea here were x-intercepts and y-intercepts. These are important because these are where the graph crosses the axis, and they're also easy points for us if we are trying to graph something or trying to kind of identify some prominent places on a graph. So let's just draw this. And so in this case, if I was looking at this graph, my x-intercept is here, and I might call that point, let's say, that's at 1, 2, 3, and 0. And then my y-intercept is here, and I might call that point 0 because x is 0, and -2. And so we can use those points. We can figure out what those points are, and that will help us graph things. And they're also just other identifiers on the graph. In lesson 3.2, we were solving linear equations by graphing. And in a lot of these problems, we were talking about something called roots. Roots are just another name for x-intercepts. Another word for that is zeros. And another name for that is just solutions. And so whenever we want to find the root of an equation, there's only one root for a linear equation because it's only going to cross the x-axis one time. Straight line can only cross one time. And so if y equals 0, then we can solve the equation for what x equals when y equals 0. And we'll know where it crosses the x-axis then, and we can call that the root, the x-intercept, the 0, or the solution. In lesson 3.3, we talked about rate of change or slope. We talked about rise over run. This is just the rate at which our graph goes up or down. And we have an equation. We can do y2 minus y1 over x2 minus x1. And that's helpful for finding the slope of a graph. If we ever get 0 in the bottom of a fraction, then we have an undefined slope. It's a vertical line, and we can't divide by 0, and so we end up with an undefined situation. In lesson 3.4, we talked about direct variations. Direct variations are sweet because they're really short and simple. They come in this form, y equals kx. There is no plus anything. That's not true. And so it's just y equals kx. We have to look for k when we're dealing with these, and we often say things like this. Y varies directly as x. That's because every time x goes up, y goes up, and if x goes down, y goes down. When we say y varies directly as x, we need to find out what k is. We can find out what k is if we solve for k, and we just do y over x. And so anytime they give us a y and an x, we can just put the y over the x, and we have the slope of the graph. So whenever we say k, we're talking about slope. In lesson 3.5, we talked about arithmetic sequences, and that's just where we have a list of numbers, and to get each subsequent number, we're going to add or subtract a constant difference. We had a formula here, it looked like this, a sub n equals a sub 1 plus n minus 1 times d. And that formula will help us to write an equation so that we can predict something like the thousandth number in the sequence or something like that. Whenever we are looking at a sequence like 6, 11, 16, 21, the way we want to find d, which is our common difference, or the number that we're going to add every time, we want to just go backwards. We want to do 21 minus 16, and that'll give us the number. We can keep doing that. 16 minus 11 is 5, and 11 minus 6 is 5, like that. That's how we want to get that common difference. Okay, when we got to lesson 3.6, we were really just talking about direct variations again. Proportional relationships are direct variations, and they go through the origin. I don't know if we said that about direct variations up here, but it's true for proportional relationships or direct variations. They always cross right through the origin, like that. And then they go up or down, and they have slope. If we have something that is not proportional, then we're going to have something that has y equals kx, but we're going to have something out here, something. Later we're going to call this, we're going to do this in the next chapter, but we're going to call km the same thing, and we're going to do this plus b. That'll be our y-intercept. B equals our y-intercept. So whenever we have a non-proportional relationship, our y-intercept is something other than 0. We're not going to cross to the origin. We're going to cross a little above or a little below, and that creates just a little bit more complicated relationship. We can't just put y over x. It's not directly proportional anymore. We're just a little offset by some starting amount that causes us to cross the y-axis somewhere other than 0.